We're going to start our last chapter next week, but today we are finishing up radicals by learning how to graph them. So we'll be graphing functions, equations, whatever you'd want to call them. They are equations and they're also functions because we're graphing them. You will hopefully be able to describe a vertical and horizontal translation before the end of the period. That is part of your assessment, as well as being able to describe a vertical versus a horizontal translation. So let me show you the mother function of radicals. So I hope you already know it's going to start out with y equals, because that's what all mother functions start out with. So square root symbol right there, and then an x. Ooh, look at that. So there's the mother function, y equals radical x. I'm going to move it over a little bit so you can see it a little bit better. You should notice, that's only in quadrant 1. I have all positive answers there. I wonder why that is. Well, it's because we have a radical. And remember, your answer has to be a positive, and you have to take the square root of a positive number to be able to work in algebra. So it's curved. It starts at 0, and then it curves up. Let me use my pen to show you. So if I hadn't shown you this, what you would do is make yourself a little table, remembering that we can't put negatives into the table. So you would do like 0, 1, 2, 3. I'm just going to do those first 3. The square root of 0, oh, that's not working. I need perfect squares. So 4 would be my perfect square. The square root of 4, oh, 1 worked. Square root of 1 is 1. The square root of 4 is 2. My next perfect square would be 9, and the square root of 9 is 3. So you notice that it starts to jump really quickly for your x's, but not so quickly for your y's. So here, I'll just point. Here's 0, 0 right there. Here is 4, 2. Here is 9, 3 right there. So what you're doing when you're making these tables is coming up with something that will give you perfect squares so that you're able to graph it. And then notice it just kind of curves up, but not super quickly, because you're taking the square root of it. You're not squaring it. When you square it, it jumps up really quickly. When you take the square root, it just kind of goes up a little bit as it goes. And then we can change that by doing what's called a translation. We've done this before this year with absolute value. Remember, we shifted them up, we shifted them down, we shifted them left, we shifted them right. I'm not going to put a number in yet. I'm going to ask you to guess what happens. If I were to put a +2 at the end of this problem outside of the radical symbol, please tell me what you think would happen to the mother function graph. The 2 people who did answer said that they think it would move up 2 spots. One person specifically said the x-axis, the y-axis. Look at that. You were correct. It's the exact same graph moved up 2 spots. So you'll notice it's kind of like when we did y-intercepts, right? The first one didn't have a number, so it started at 0. The second one did have a number, so it should have started at 2. I'd like everybody to take a guess this time. What do you think is going to happen if I do the exact same problem again, but I put a -2 at the back of it? I should hear or see more responses this time. I'm going to get rid of the plus and put a minus. So in the chat, what do you think is going to happen if I change it to radical x -2? Okay. So we've got a lot of people putting move down. One person said x-axis. You can't move down the x-axis. The x-axis goes this way, horizontally. So it would either move left or right if you're saying the x-axis. All right, let's see if you guys are right. Is this going to move the mother function down? Oh, look at that. You are correct. Look at how pretty that looks. So mother function starts at 0. It curves upwards. And when you're making your graph, you will just have to make a table to see exactly where the numbers are. So here it was the square root of 4 is 2. Here it was the square root of 9 is 3, so on and so forth. What do you think the mother function will do if I put radical x plus 2, the x plus 2 under the radical? I'll give you a clue. I talked about horizontal and vertical shifts in the agenda. What could it be? So one person said just generically, it will move to the side 2 spots. Another person said move over on the x-axis. But someone said specifically, they think it's going to move right 2 spots. Let's see if you are correct. Let me hit backspace and +2. Oh, it moved to the left. If you remember when we did absolute value, remember it shifts the opposite way of what we expect. And remember that's because, well, I'm going to circle it right here. That's the point -2, 0. Well, in order for this to be 0, that x needs to be -2, right? 2 minus 2 equals 0. If you had it be +2, then you would get 2 plus 2 is 4, and the square root of 4 is 2, not 0. That would be the 0.42, not -2, 0. So when we're doing vertical shifts, it's exactly what it looks like. If it says +2, we're going to shift up 2. If it says -2, we're going to shift down 2. And that's when it's on the outside. So I don't know if you want to take a picture of this. So the generic thing is to just use K. So if you see something like this, that's the generic function. That means to shift up. And if you see y equals radical x minus k, that means to shift down. But if you see it inside of it, that means to shift left, because you need the opposite of positive k to make 0. And if you see a negative in here, that would shift right, because you need the opposite to make it 0. So let's start with 21. I'm going to write it down, and I'm going to go to my graph paper. So if you're using your graph paper, then you would do 17. If you're going to go in order, you would do 17, 19, 21. And we've got -3 radical x. It probably actually was y equals -3 times the square root of x. Okay, so here's my table of values. And this one, because it's just a radical x and there's nothing else inside of it, I need perfect squares. So 0 is a perfect square. 1, I can take the square root of. 4, I can take the square root of. And 9, I can take the square root of. Notice I didn't number these because that -3 is going to mess everything up. So I need to take the square root, and then I need to multiply by -3, which is going to make that last one really, really big. So I'm going to leave that off. So the square root of 0 is 0, and 0 times -3 is 0. The square root of 1 is 1, and 1 times -3 is -3. And the square root of 4 is 2. Oh, I can do that 9. Square root of 4 is 2, and 2 times -3 is -6. I'm going to leave that 9 there. The square root of 9 is 3. Oh, no, that's too much. 9 times -3 is -18. So I've got 3 points. I can curve it from there pretty well, or at least close enough to get the idea of what the graph would look like. So here is 0, 0. Here is 1, 2, 3. Close enough. And then 4, -6. 1, 2, 3, 4. Okay, I cannot see that very well. I think that's -6. Okay, so look, we don't have a graph that's in quadrant 1 anymore, and that's because there was a -3 on the outside. It's still going to curve. You can see that it's curving. I'm just going to try my best. And then I'm going to put an arrow because this does keep going, but I'm not putting an arrow at the very top. Why? Because it doesn't go past 0. Remember, we can't take the square root of a negative, so it cannot go past the 0. So don't put an arrow at the beginning, just put an arrow at the end. Well, let's do 23. Okay, so I'm going to go back to my graph paper. I am going to try to clear this. There we go. And I'm just going to do 23 here. Okay, so I don't know if I'm copying it right. It may be f of x instead of y. I don't know. But I know that this part was the square root of x over 2. Okay, so here's where it's important that you're picking numbers that you can actually take the square root of without a calculator. If you have to use a calculator, then there's no way you're going to graph it properly. It's going to be all weird because they're decimals. So we want 0 is perfectly fine because I can take half of 0 and it's still 0, and the square root of 0 is still 0. So 0 is a perfect number to pick no matter what you're doing, as long as it's multiplication or division. All right, but then if I put a 1 there, it would become 1/2. And I don't know the square root of 1/2. So I actually want a 2 here, because if I plug in a 2, 2 divided by 2 is 1, and I know the square root of 1, it's 1. And the next perfect square is 4, so I need that fraction to equal 4. Well, the thing that I could replace x with to give me a 4 would be 8. Okay, so if I use 8 as my last number, because then it's going to get way too big if I use anything differently. If I use 8 as my last number, and then I plug it into the radical, 8 divided by 2 is 4, and the square root of 4 is 2. Now I have 3 good points that I can graph and try to curve to make my graph complete. So here's 0, 0. There's about 2, 1. It's about there. I think I'm up too high. I think I'm at 8, 3-ish, but close enough. So then we're going to curve. I totally missed it. I'm okay with you missing it a little bit. It is a sketch. Remembering not to put an arrow at the beginning because we can't take the square root of a negative, but it does keep going. You could keep graphing this forever and ever and ever and ever. I don't know why. That section is way easier than the one we just did. They're all just shifting. Every single one of those is either just shifting left, shifting right, shifting up, or shifting down. So I'm just going to do that for you. I'm going to put what the shift should be. I might make mistakes on purpose, and you need to tell me in the chat where I made a mistake. So I'm going to put R for right, L for left, U for up, and D for down. Okay, so for 31, I'm saying is down. 33, I'm saying is right. 35, I'm saying is left. 37, I'm saying is left. Oh, I put the whole word instead of the letter. All right, I did make mistakes. I did make more than one mistake. I'd like you to let me know in the chat what you think I made a mistake on. So, looks like you guys have caught me. Remember, you are doing the opposite of what you see. You are correct. I made mistakes on 33 and 35. 33 should have been shifted to the left because we need to do a 0. 35 should have been shifted to the right 4 spots. So notice it doesn't ask you to make a table of values. You're just taking that basic mother function and moving it up. So or down or left or right. So for 31, that's the only one that's actually a vertical shift. So 31, you're going to just take that mother function and start at -5, and it's going to curve just like those pictures above. 33, 35, and 37, you're going to either shift left or right. That one's wrong. That one's wrong. That should be left for 33 and right for 35.